Welcome to Study Loop.
This is the answer to Chapter 12, problem number 77 from the Smith Organic Chemistry textbook. And in this problem, we're asked to draw a mechanism, a stepwise mechanism for this reaction where we go from this multi-ring system and add the product that we have after MCPBA is used. So metachlorobenzoic acid. And so what we need to recognize when we're looking at just what we're given here in the problem, we need to recognize that we're going to do an epoxidation on that double bond. And then the leftover product after the MCPBA epoxidation, the metachlorobenzoic acid, is going to act as a nucleophile and add to the epoxide. And so that's what's going on. And once we realize that, we need to just draw a mechanism for it. And so the other thing that I'd like to draw your attention to, and I will red arrow it here. So rather than redraw the other two rings of this starting material that don't participate in this reaction at all, I've used this notation where I draw the two branches coming off of the ring that is going to participate and connect them by a squiggly line, just to show that that there are other rings over there. And really, it's a waste of time to continue drawing over and over again, large pieces of molecule that aren't participating at all in a reaction. And so that's the notation that I'm going to use to save time. And so the first step here is going to be just a straightforward MCPBA epoxidation. And so many things happen at once during an MCPBA epoxidation. So the double bond attacks this oxygen, while the oxygen also attacks a carbon of the double bond. Simultaneously to that, the oxygen-oxygen bond breaks, and those electrons revert. So actually, I drew that wrong. So those electrons actually revert to the oxygen-carbon bond. Simultaneous to that, one of the bonds here from this carbon-oxygen double bond is going to pick up the hydrogen from that other oxygen, and those electrons from the oxygen-hydrogen bond will revert to that oxygen. So 1, 2, 3, 4, 5 arrows in this single step. All of those things are happening at once. And that's just the typical stepwise mechanism for an MCPBA epoxidation. And so after that, we end up at this point. And so again, I'll use this notation to show that there's other stuff over here that's not participating. We have this silyl group. Okay. And so after the MCPBA epoxidation, we have an epoxide. So there we go. There's our epoxide. And as I said, we're going to have the resulting benzoic acid, the byproduct of the MCPBA epoxidation. So that looks like this. Oops. Okay. And then let me go ahead and put my lone pairs in. Okay, and so the next thing that's going to happen, as I said, the metachlorobenzoic acid that we made as a byproduct of the MCPBA is going to act as a nucleophile and attack our newly formed epoxide. So that's going to look like this. We'll attack there. These electrons will revert to this oxygen. And so now we are here. Okay. What am I missing? Oh, okay. And so this oxygen is going to have 3 lone pairs and a negative charge. And this oxygen is only going to have 1 lone pair, and so it's going to have a positive charge. Okay, and so to get from here to our final product, all we have to do is protonate the oxygen that needs to be protonated and deprotonate the oxygen that needs to be deprotonated. And so we can protonate first. And so that can be accomplished by another equivalent of the MCPBA byproduct, so the metachlorobenzoic acid. Okay, and so this oxygen, one of its lone pairs, can pick up this hydrogen. Those electrons can revert to that oxygen. Okay, and so now we've protonated that oxygen, which needs to be protonated. Okay. So I'm going to draw this arrow a little higher up so that we have more room. And just imagine how much less space we would have if, instead of using that notation that I red arrowed in the beginning, if I was drawing the entire molecule over and over again. And again, it doesn't make sense to do that when all those parts of the molecule are not actually participating in this reaction at all. So here we have an alcohol now. We protonated it in the last step. We can put everything's lone pairs in. And again, this oxygen has a positive charge on it. And so the last thing that we need to do is deprotonate that oxygen. And so that can be accomplished by an equivalent, so it can be accomplished by the conjugate base that we made in the last step. So here's the conjugate base that we made, the carboxylate ion. That can grab this proton. Those electrons can revert to this oxygen. And so that gets us to our final product here. Okay, and again, there's 2 more rings over here that I'm omitting. And our deprotonated oxygen now is back to 2 lone pairs and 2 bonds. So it's uncharged. And here is our MCPBA derivative that added in the first step. Okay, and so we can put the lone pairs in, but that's it. That's the molecule that we were asked to make. And so, again, the way to approach this problem, I think, is to recognize that we're going to have an MCPBA epoxidation, and then the byproduct of the MCPBA, the metachlorobenzoic acid, is going to act as a nucleophile and attack the epoxide that we make. And so that's the answer to chapter 12, problem number 77.